Thank you. So my name is Boris, and I am from CESNET, which is an organization managing the Czech NREN, which is the Research and Education Network. And me and my colleagues are running a, let's call it a private HPC cloud, but in some cases it's actually a public cloud because our user base is so large and so loosely restricted. Basically, they have to be in the scientific or educational community. So it's basically a public cloud just for a specific set of users. And I will talk to you a little bit about appliance management and image management in OpenNebula. This will be a fairly simple talk. It's not rocket science. It's just a few tools to help us manage our base appliances, the examples users use to instantiate their first virtual machine, or those examples they use to create their own virtual machines. So we provide some base appliances. So why provide pre-built appliances? In most cases, if you are running a cloud with users, you want them to have the opportunity to start quickly. So you want to have some base appliances, in most cases clean operating systems, pre-installed Ubuntu's, Debian, CentOS's, Scientific Linux's, depending on your community, on whatever they like to use or their tools require in most cases. So you need to generate these base appliances to give them this jumping off point or this starting point. And what is the main idea behind providing them? You want the users to have the opportunity to start immediately and also to avoid common mistakes. Because if you are an administrator and you know something about virtualization, it's not always that easy to create an appliance that will work, that will boot up in the cloud, that will be reasonably secure. It will allow you to access it remotely, again, with reasonable security. So this is again a good point to give them an example of how it should look, and something they can start, look around, look at various configuration files. Okay, they configured this like that. I can do that in my machines. So that's the reason why pre-built appliances are nice. But since we have pre-built appliances, we have to manage their lifecycle. This is a very crude diagram of what the virtual appliance lifecycle looks like. As you would expect, you have to create it, then you publish it, and lives in your OpenNebula. Users hopefully use it, then you can update it, publish it again, they will use it again, or it will expire, which is always a good choice because you shouldn't have these base images uploaded indefinitely for various reasons, security being a very important one, because since the image is dormant in OpenNebula, it's not running, automatic updates will not work. So it's a good idea to have some sort of a replacement cycle, even if the image hasn't been used. Every month, simply replace it with a new copy, completely up-to-date copy. You can of course shorten this cycle if an important security fix is available. By all means, generate immediately and start uploading. But this is the life cycle. And if you decide to discontinue that image, why not? No one has been using it for years. There is no need to generate it again. So you can discontinue. As we heard many times during this conference, automation is important. And this is one of the tasks that is really important, or really a good candidate for automation, because you are doing the same things again and again and again. You need to generate that image, so you have to install a vanilla operating system that's almost always the same, and most installers have some sort of preseed files, so you don't have to do it manually. Then you apply some configuration, minor changes, maybe install some utilities, maybe some software, usually at least contextualization packages for OpenNebula or Cloud Init or whatever. So again, excellent candidate for automation. As I mentioned, the appliance is basically a clean operating system with some configurations. Maybe you want to hide some details of your infrastructure from users. You need to install drivers or paravirtualization drivers, guest utilities, or for example, we have systems we need our virtual machines integrated with. So for example, we use a tool called Pakiti, which is used to check the patching status of running virtual machines. So it can report long-running virtual machines which have not been updated. So we would like to have these clients of this system pre-installed in all our base appliances. So integration, yeah, install whatever package you need. It will be always present in your base images. Then the other problem, once the image is generated and ready to be used, is how to do the actual distribution. If you are running one cloud with one endpoint in a single site, all right, you can do it manually, a few clicks or a single script, and it's done. But if you are running multiple clouds, or you have a federated version of OpenNebula where you would like to upload the same appliance into multiple separate OpenNebula instances, or you have a massive infrastructure with completely separated OpenNebulas, you need a mechanism to do that. So you can use, for example, the OpenNebula Marketplace, because it is a tool for sharing images. But something that's missing is somehow to subscribe or to receive updates, because your base appliance is non-persistent. It is basically read-only for all users. And if someone updates the original appliance with a potentially important update, security fix or bug fix or whatever, you would like to receive this new version. So that's an important feature which is provided by our tool, but we are also considering integrating with the OpenNebula Marketplace to somehow close the circle and make it available in different ways. And once you find a way to subscribe and distribute these images, you have to think about making them available to users. Because in OpenNebula, this appliance is basically a blob, an image containing the file system, which you can upload to OpenNebula and create an image. But to launch a virtual machine, you need a template. So with every change, you can possibly need to modify the template, or you need new templates, remove old templates. So this is also something that is a good candidate for automation, because let's face it, most of these templates are generic and are the same. You connect one disk, one default network, assign one CPU and 1 GB of memory or something like that, and you are done. So there is no need to do this manually. And in some cases, if you are part of a larger infrastructure, you have to reuse existing tools. So, for example, we as an NGI, National Grid Initiative, we are part of the EGI, European Grid Infrastructure, and we are running an instance or a site in EGI Federated Cloud, and they have their own image distribution mechanisms and policies. So we also have to connect to an external system feeding us images. So that's also a good point where you want to consider automation, because you don't want to have an administrator checking his email and waiting for a new image that has just arrived, and the administrator has to create a template and upload it. So this is also a consideration. In the case of EGI, they are using the EGI application database and some tools provided by the high energy physics community, HAPIX, VMcaster, and VM Catcher. If you are interested, you can look at those links and read more about those. They are basically a distribution system which ensures image integrity and thus endorsement, and works with X509 certificates and signatures. So you can actually ensure that the image that has arrived is trusted. You can check the signature and stuff like that. Okay, so this is the big picture. You have the user, or the administrator, whoever wants to generate an appliance. In most cases, yeah, an automated system will trigger a build, or administrator can manually trigger a build and generate an appliance. Or the user can use it on his own or her own laptop and generate an image, and then take this image or send it down the chain to the synchronization utility, which will handle OpenNebula upload and modifications. Or you can go through the EGI process, where you can generate the image, register it in the applications database. It will be then synchronized to another part of the tool, which handles newly arrived images from VMcaster VMcatcher, and it will convert the image to the appropriate format, and then again trigger uploads into OpenNebula. And these three tools in the middle, that's the main point of this talk. So the first one, which we called Comfy, is the appliance generation tool. So it's a really simple wrapper on top of Packer IO. I guess you encountered it. So it mostly handles user input, some metadata generation, and then relies on Packer and VirtualBox to generate the image itself. So what we aimed for is to actually reduce the amount of work we need to do. So we simply wrote a wrapper around existing technologies to handle some metadata we need for the later steps in the process. Basically, we need some metadata to upload into OpenNebula to know the formats, to know the right groups or permissions. So this is actually included and somehow processed by this wrapper, but the image generation itself is done by Packer and in VirtualBox. We of course use their provisioning features, so you can run shell scripts, or you can include some other provisioning tools to modify your image after it has been installed, and then we create the descriptor needed for later phases of this process. So that's the first step when you want to generate a new image. When a new image arrives from an external system, in this case from the EGI applications database, it will arrive as an event processed by VMcatcher, and VMcatcher will notify this tool Ichi, which will handle the event and decide what to do. The events received from VMcatcher have there are many different event types. The most important ones are new image or image update, and expired image or remove image. So these two are currently handled, and we rely on VMcatcher to do the hard work. So it will check the signatures, verify the image integrity. It will download the image, and Ichi will simply convert the image into the pre-configured format. Because since we are getting these images from an external system, there is no way to know or ensure they are in the right format for our hypervisor, our OpenNebula. So Ichi is doing the conversion process. You can configure, okay, I received an OVA archive, so unpack it and take that image and convert it into QCOW and then send it down the chain. So we can actually integrate everything into one working system, and at the end you should always receive the right format, the right image format with the right metadata for upload into OpenNebula. And again, it generates the JSON descriptor used for later uploads. And the last tool is called Nifty, and this is actually the tool handling uploads into OpenNebula. So as I mentioned before, it will read this JSON descriptor. It's a very simple descriptor, maybe user groups, layout of the disk, so I know that disk should be attached as the first one. This is the operating system disk. Maybe these are the data disks, and stuff like that. Not really that important. It will handle events. From Comfy, the only event will be new image or update image. From Itchy, it can receive new images or receive expire events. An expire event will not contain an image. It will be simply an information, okay, look up this appliance in OpenNebula and disable it, which means rename it, remove permissions so users can no longer instantiate it. That's the other important event. And then it takes care of registering images, so it will do the upload. There are some transfer drivers, so if your OpenNebula is remote, it is able to SCP or rsync the image into a separate location and then simply trigger upload from OpenNebula. And then it will create the corresponding templates, so you don't have to. There is a template of templates or meta template where you can actually predefine your generic OpenNebula template with some simple variables. In most cases, put the disk here. And that's everything. That's done by Nifty, and then it will register the template, set the correct permissions, change group, change zone, whatever you need, and the appliance is ready for the user. So what's our future work or our roadmap? These tools are brand new, so we need to do a lot of work in documentation. We need usage examples, we need extensive testing, we need to make the first stable release, basically. And we also need to start deploying it in production. The part which fits into the EGA federated cloud will be deployed in the EGA federated cloud. The part that fits into our internal infrastructure will be deployed in our infrastructure. And we would also like to look into a better integration with OpenNebula, especially with the marketplace, because that's the logical place to make these images available, or maybe even set up a system where you can subscribe to images from the marketplace. So we actually take the marketplace image and register it in OpenNebula and receive updates. That's also a possibility. So that's probably all from me. You are welcome to talk to me after the presentation, or email us, or just simply explore our open source repositories on GitHub. But just be warned, it's quite a new set of tools. There will be problems, we need to fix them, but we are happy to receive any feedback, comments, something you would like to see, or if it's complete nonsense, let me know. We can change it, or if you have a better tool, better developed, or that can better fit this problem, just let us know, and we can discuss that and maybe improve each other's work, or destroy my work and improve yours. That's also a possibility. So, thank you.